Okay, so this is, I'm going to work several problems from AP Calculus Practice Exam AB3. All right, where we left off in class was at number 21. All right, in 21, the question is, we want to integrate 1 to 3 of 2 minus the absolute value of x minus 2 dx. Alright, so here is how you integrate absolute value. What we have to do is, really, if you want to think about it, we have to split it up into two parts. So it's between 1 and 2, we want to do 2 plus x minus 2. So we're just plussing and minusing this absolute value, dx. So that's the first half. That's from 1 to 2. Plus, then we're going to go from 2 to 3. So the whole thing is 1 to 3, 2 to 3 of 2 minus x minus 2. Okay, so the 2 and the negative 2 go away, so we're from 1 to 2 of just x plus 2 to 3, and then I have 2 minus x plus 2, so that'd be 4 plus x, 4 minus x dx. So this is going to be 1/2 x squared from 1 to 2 plus, and then integrating 4 minus x, that's going to be 4x minus 1/2 x squared from 2 to 3. Okay, so that's 1/2 times 2 squared minus 1/2 times 1 squared plus 4 times 3 minus 1/2 times 3 squared minus 4 times 2 minus 1/2 times 2 squared. So 2 squared is 4, half of that would be 2, minus 1/2 plus 12, 4 times 3, 12, minus 9/2 minus 8 minus 2. Wow, what a mess. Okay, so if we can get all of this into halves, that'd be 4/2 minus 1/2 plus 24/2 minus 9/2, and then this is 6, so minus 12/2. Okay, so that's 4 minus 1 is 3, plus 24 is 27, minus 9 is 18, minus 12 is 6, so that's just 6 over 2, which is 3. Right, so that one would take a little bit. You definitely end up using more than 2 minutes on that problem. Okay, so that is number 21. Okay, number 22 this is just finding a derivative using the quotient rule. So it is y is equal to 3x plus 1 over x minus 1. Okay, so dy dx is going to be the bottom, x minus 1, times the derivative of the top, which is 3, minus the top, 3x plus 1, right, times the derivative of the bottom, which is just 1, all over the bottom squared. X minus 1 all squared. Okay, that's going to be 3x minus 3, distributing the top, minus 3x minus 1 over x minus 1 all squared. And then the 3x's cancel, and negative 3, negative 1 makes negative 4 over x minus 1 all squared. And that is going to be A. Okay, and the previous answer, number 21, was D. 21 was D. All right, so that's it for number 22. '23. Okay, so we're taking a derivative, and we've got an integral in here. So we've worked a couple of these, going from x to 2, the natural log of 1 plus t dt. So in order to use the fundamental theorem of calculus, we have to take this x value and put it up into the top position on the integrand. So the way that you can do that is if you put a negative out front, you can switch the two places. So that'd be 2 to x of the natural log of 1 plus t dt. All right, so the way that you take the derivative of this is, okay, this is going to be minus the natural log, and you plug x in for t of 1 plus x, and then you multiply times the derivative, or by the derivative of the upper limit, which in this case is just 1. So the answer is minus the natural log of 1 plus x, and that is C. Okay, so that is number 23. 24. Okay, 24 says f prime of x is equal to negative 5 times x minus 3 all squared times x minus 2. And then it says, which of the following features does the graph have? Okay, so this is a derivative. We want to set that equal to 0 and get the critical points. So the critical points, what makes this 0 would be when x is 3 and also when x is 2. So we can do a sine line, put our critical points on there. To the left of 2, I would pick 1. Well, squaring that makes it positive. And then that's negative, so you'd have a negative times a positive times a negative, so that would be positive. And then between 2 and 3, maybe 2.5. Okay, that's going to be positive, positive, negative, so that would be negative. Then greater than 3, anything you want. Let's try 10. Positive, positive, but still negative out front, so that's negative. So what we have, we know we have a max at x equals 2 and we don't have a minimum at x equals 3. So looking at the options, right, looking up at the options here, part A says we have a minimum at x equals 2, so that's not true, that's out. Part B says a maximum at 2 and a minimum at 3. Well, that's not true. We don't have a minimum at 3, so B is out. C says we have a minimum at 3, so it's out. D says we have a minimum at 2, which is wrong. So the only thing that leaves is E, all right, which is a local maximum at 2 and point of inflection at 3. And we don't even have to figure out about the point of inflection because A through D are all false. So that covers number 24. Right, 25 I think I can fit on this board here. Says if 0 to b of f of x dx is equal to 3a, and the graph of f is symmetric about the origin, then what is negative b to b of f of x dx? Okay, so symmetry implies that 0 to b of f of x dx is equal to negative b to 0 of f of x dx. Okay, so we're going from negative b to b. So halfway, negative b to 0 has to be the negative of the other. So if 0 to b is 3a, then the other side of that, the symmetric side, which we had to make negative, is going to be negative 3a. So that's going to be 0, which is selection A. All right, don't sweat the whole symmetry stuff. We didn't really work on that in class. There's typically not a lot of questions about that. You might get one, but this is how you do it. Okay, 26. Hey, 26 is a good one. It's not too hard. We didn't do a whole lot like this, but it reads, we have from 1 to k, so just have a constant there of 1 over the square root of x dx is equal to 4. And we want to know, what is k equal? Okay, well, let's rewrite that 1 over the square root of x as x to the minus 1/2. Okay, so if we integrate that, that's going to be 2x to the 1/2. And we're going from 1 to k, and that's equal to 4. So let's plug in k. That's going to be 2 times k to the 1/2 minus 2 times 1 to the 1/2 is equal to 4. Okay, so that just means 2k to the 1/2, and 2 times 1 to the 1/2 is just 2, so that's equal to 6. And we take that 2 and put it on the right side, so k to the 1/2 is equal to 3. So the square root of what would give us 3? That is 9. Alright, so k is 9, so that is choice C. Okay, you'll probably definitely get something like that you'll have to do, where you have to figure out the value of one of the limits on the integrand. Okay, 27 says the area of a region bounded by the graphs of y equals sine x and y equals cosine x and the x-axis between 0 and pi over 2. Well, in order to get this one, you got to remember what the graph of sine and cosine is. So the graph of sine goes like this. Okay, so you don't have your calculator during this part. Okay, and this is pi right here. Graph of cosine starts up here, goes down, and it crosses, cosine is 0 at pi over 2. So what we're worried about is this right here. Now, where do the two cross? Okay, this is cosine x, this is sine x. Well, cosine and sine are equal at pi over 4, excuse me. Okay, and then this point right here is pi over 2. So to get the area, we'll have to split it up into two parts. We're going from 0 to pi over 4. And sine is on top, so sine x dx plus pi over 2, pi over 4 to pi over 2, and then cosine x is on top. Alright, and looking through the options on that, that matches option E. Okay, and finally, number 28, we have a graph, and we want to know what is the value of the integral from 0 to 6 of f of x dx. Okay, so just the graph from 0 to 6 is the part that we need to look at, and you can see it goes like this, and then it goes down like that. Okay, so this is at 3, this is at 0, and then that's at 6 right there. Okay, and it crosses here at 4. This just tells us an area under the curve.